Hello everybody and welcome to Python as fast as possible. In this video, I'm going to be trying to teach you Python as quickly as I possibly can. That means I am going to go over things quite quickly. I'm going to talk very fast, and I will note that this is not for absolute beginners. If you are looking for a beginner level tutorial series, I have many on my channel. I will link a ton of resources down below, and if you feel that I missed anything or made any mistakes, please do leave a comment. With that being said, let's go ahead and get started and get into Python as fast as possible. To get started, we need to download and install Python. Please download the most recent version of Python from the Python website, which will be linked in the description. If you're using any version of Python which is below 3.6, that will not be compatible with this tutorial. When downloading, please check the box that says Add Python to Path. This will make your life easier in the future. Now, Python automatically comes with its own environment to write code in. This is IDLE. You can use this to write your code if you'd like, but I prefer to use Visual Studio Code, which is a text editor. To download that, you can go to the link in the description and just download the stable build for whatever operating system you're on. Now, if you're using VS Code, there is one little bit of setup we need to do to get started here. We simply need to install the Python extension. Go to the extension tab here. This will bring us to the VS Code Marketplace. We can type Python, and then we can see the Python extension and simply press install. You can see for myself, I already have it installed. So before we get started, I thought it would be a good idea to talk to you about some of the things that Python is used for. Here I am on my channel in the playlist tab, and you can see a bunch of different playlists just giving you an idea of some of the things that I've created with Python and taught on this channel. Python is a general purpose programming language. It is very easy to learn, versatile, and really easy to write in. The core advantage of Python is typically how simple it is, how easy the syntax is to read, and just how fast development is with it. That being said, Python is mostly used on the web and in machine learning, artificial intelligence, and data science related tasks. Now, the sponsor of our video knows a ton about that, and that is Simplilearn. I need to thank Simplilearn for sponsoring this video and giving you all a discount on their Data Scientist Master Program that was co-developed with IBM. This program is comprised of 6 unique courses that implement a unique, blended learning experience in a high-engagement online classroom environment. During this program, you will master 30+ in-demand skills and work with tools and languages like R, SAS, Python, Tableau, Hadoop, and Spark. You'll master these skills through 15 real-life projects and 1 capstone project during this 12-month comprehensive course. You'll also be given $1,200 USD worth of IBM Cloud credits to use during your 24/7 access to the IBM Watson platform. After completion of this course, you'll be given certificates from IBM and Simplilearn to testify to your skills as an expert in data science. Get started by hitting the link in the description. I want to start by covering the core data types in Python. These are int, float, string, and bool, int otherwise known as integer. Now, an integer or int is simply any whole number that does not have a decimal point on it. So 23737, that was going to be an int. -9, that's an int. Negative some random large number is an int. So long as it does not have a decimal point on it, we consider it an int. A float is almost the opposite of that. It is simply any number that has a decimal point on it. So something like 272.0, this is a float, even though you would consider this a whole number. The 0.0 adds a level of precision to this, which makes it a float. Of course, something like 9.7 would be a float. Whenever you see a decimal point, that means the number is a float. Next, we have string. A string is simply anything surrounded by single or double quotation marks. Typically, we consider this a sequence of characters or numbers. So if I type something like hello, and I type something like hello, these two strings are actually completely equivalent. It does not matter whether you use single or double quotation marks, there is no difference. I will note that if you want to embed a double quotation mark or single quotation mark in the actual string itself, then you would usually wrap the string with the opposite type of quotation mark. So in this case, I want to have this double quotation mark inside the string, so I wrap the string with single quotation marks. Now, just to note here, if I do something like 4.6, even though you might consider this a float, this is a string, again, because it is surrounded by single or double quotation marks. Remember the definition, anything defined or surrounded, by single or double quotation marks. Next, we have Boolean. This is one of 2 values. We have true or we have false. Some people may consider this 1 and consider this 0. We're going to look at these later on and you'll see why that's important, but that is a Boolean value, and these are the 4 core data types in Python. The next topic I'd like to cover is output and printing. This is very important and we will be doing this a lot in this video. In Python, there's a simple function called print. This is how you output something to the console when you run your program. Typically, when you print something, you'll put it in strings. So I want to print, say, hello world. So I will print the string hello world like that. And if I run my program by pressing this run button, you can see down here in the console, we get hello world. Now notice that if I just type hello world like this and I don't put it inside of a string and I run my program, I will get an error. This is because I cannot simply print something like this. The program does not know how to interpret hello world if it is not wrapped in strings. That is because this is not one of the core data types and we have no variable or anything that denotes what hello world is. That being said, if I want to print a number, say like 4.5, Python knows what 4.5 is because it is a float. You can see when I highlight it, it says float. If I run this, it will print 4.5 out and there will be no problems. Now, if you want to print multiple things, what you can do is separate them by commas. So say I'd like to print 4.5 and then I would like to print hello. When I do this, it will automatically add a space between the two things. Let's just put another string here just to show you what I mean. So 4.5 hello, notice it adds that space in between. Now we will talk about how you can print things without the space in between later on, but that is the basics of a print. If I want to print many things on the same line, I can go hello, I could say end, I can say 87, I can say false, and I can run this and this will all work. Hello and 87 false. Now there's a few arguments that you can pass into the print function. If you do a comma and then type end equals, you can denote what you want the end of this print statement to be. By default, the end here is a carriage return, which is \n. What that means is go to the next line after this line is printed. Now notice if I don't add this \n, or in fact, let me just show you what happens by default. So let's say I have hello and 87. I'm going to get rid of this and I print both these things out. We get these on two separate lines. That is the default behavior of the print statement. It prints on a new line. Now notice if I add end equals and instead of a \n, let's say this pipe like that, and I run this, now at the end of the print statement, it simply prints a pipe. It does not add the carriage return, which means we do not move on to the next line. That's a little bit more advanced, but essentially the carriage return is that \n, and again, that means just move down to the next line. That is the basics of printing and output, and now let's move on. Next, let's move on to variables. Variables are an important part of any program. In Python, they are quite easy to create. When you create a variable in Python, you simply type a variable name, a space, an equal sign, and then assign it to some value. This value is going to be some data type, some function, something else that we'll talk about later on. To give you a basic example, I'm going to set the variable hello equal to the value Tim. Think of a variable like a bucket that stores some data or stores some type. Now, if I want to access the value that is stored in hello, what I can do is I can simply say print hello. What this will do is it will say, okay, this is a variable. I know it's a variable because I saw it earlier on the program. Let me see what its value is, and I will print that value. So now I'm going to run, and you can see that we get Tim. Let's make another variable. Let's call this world. Let's actually set this equal to the value world. Now let's print hello, comma world, and let's see what we get. We get Tim and then space world. Variables are somewhat complex. You can make them equal to other variables. If I decide to change the value of world to actually be equal to the variable hello, what's going to happen is they're going to say, okay, hello is a variable. What is hello equal to? Hello is equal to Tim, so I will print Tim. Now watch what we're going to get. We get Tim. Now what happens if I come here and I change hello to be equal to no? If I do this, what's going to happen is world will not change because world was set equal to the value of hello at this line. At this point in time, line 3, because our program reads from top to bottom, the value of hello was Tim. So world gets set to Tim. Then hello gets set to no. That does not change the value of world. So what you're going to see is we're going to have Tim, and then we're going to have no. So let's have a look here. And sorry, other way around, we get no Tim. My bad there, we printed a hello first and then world. I had that mixed up. That is the basics of variables. There's many other things that we can do with them, but let me just tell you about the naming conventions for them. So in a variable, you are not allowed to have any special characters and you cannot start with a number. So you are allowed to have an underscore. That is the only exception in terms of special characters. Usually you will use that when you are denoting a space. And in Python, the convention is typically to separate things using an underscore. In other languages, you may see something like hello world if you wanted to make a variable that has multiple words in it. But in Python, stick with snake case, which is what this is known as. The other one is camel case, and use underscores to separate your variables. Just to give you an example of what I mean, you cannot start a variable with a number. So 9 hello, notice I'm getting the red line popping up here. And I could not do something like hello 9, that does not work. But if I want to do hello world 32, that is totally fine. That is a valid variable name. The next topic I want to talk about is getting user input. Just like printing something is very simple, getting input is simple as well. What we do is we simply use the input function. We have our open and close parentheses, and then we type what's known as a prompt inside of these brackets like this. Now this does need to be in a string. Unlike the print statement, we cannot do something like 4.5 in here. That will not work. We do need a string. So what I'm going to do is I'm going to add a prompt. Say I want the user to type their name, then I will say name, I will do a colon, and then I will add a space between the colon and the end of the string. The reason for this is that the user will be able to start typing on this line right after the prompt. So if I don't have a space, then what's going to happen is the user will start typing right where the colon is, which of course is not going to be good. So let's go ahead and run this and have a look at what happens. We can say name, colon, space, and now I'm going to type Tim. That's great, but how do we actually get the value? How do we store what the user typed in so we can use it later? Well, we need to assign this input to a variable. So what I'm going to do is I'm going to say name is equal to input. I just want to note, because I forgot to say this previously, we could have capitals in our variable name if we want. That would be fine, but I'm not going to do that. And now what will happen is whatever we type in will be returned to us in this statement as a string, and it will be assigned to this variable name. So if I go ahead and print the value of name, what's going to happen is whatever we type in here will be printed out. So let's have a look at this name. Let's type Tim, and we see that Tim is printed out below there. Now we of course can get multiple user input. So I can say something like age equals input age colon, and now let's see what happens when I run this. So we go name, Tim, age 20, and we could print those out if we want, but I'm not going to. Actually, you know what? Let me show you one example where I print them out. Let's say hello, and then let's go comma name, and then you are comma age years old. So this is a way that we can combine variables and strings so that we print out a meaningful response that says hello, whatever the name is, you are whatever the age is, years old. So in this case, I'll say name Tim, age, let's go 12, and it says, hello, Tim, you are 12 years old. All right, so that is it for input. Now we're going to move on and talk about how we can actually convert, say, numeric input into a integer or float, because it default comes back as a string. All right, so the next topic I want to cover is arithmetic operators. These essentially are like plus, minus, multiplication, exponent, how you perform mathematical operations in Python. Now, just something to keep in mind when we're performing and using arithmetic operators, we have to make sure that the data types on the left and right-hand side of these operators, otherwise known as the operands, are the same data type or are both numbers. What I mean by this is if I have something like hello and I try to add 9 to it, well, that just does not make any sense, and we are going to get a error and something's going to be wrong with our program. So just keep that in mind. I cannot do hello minus 9, cannot do hello divided by 9. You actually can use the multiplication. You can take a guess at what that's going to do, but I will show you that later. All right, so let's go through the basic operators. The first one is the plus sign, very straightforward. We can add 9 plus 3, or in this case, I could add x plus y. So x is 9, y is 3. We can add those two values together. Ignore the squiggly when I save, that goes away. Now, something to keep in mind, if I make this 3.5, this works totally fine. Even though these are different data types, since they're both numbers, I can add them together. Of course, I can do the subtraction. Let's run that. I can do the multiplication, which is an asterisk, and I can do the division. When we do the division, we get some crazy number. Just keep in mind that the maximum precision in Python, I believe, is 13 decimal points. There is ways to get beyond that, but that is kind of too advanced. I'm not going to cover that right here. And when you ever do division or you're dealing with rounding and all of that, that's always a problem in computers. So just keep that in mind. You're not going to get the most precise answers with division like this if this is a non-terminating decimal point. Anyways, hopefully that makes sense. Now, I just want to point something out. If I actually have, say, 9 over 3, of course, you know that that answer is 3, and that is a whole number, right? 3 is a whole number. But this is actually returning to us a float, not an int, even though neither of these data types are a float. The reason for that is because whenever we use the division operator, it returns a float because it does not know if it's going to need to represent a floating point or it's going to have to represent some level of precision. So just keep that in mind. If for some reason you don't want this to be a float, of course you can convert the result to an int by just doing int like that. Okay, so those are some of the basic arithmetic operators. Next, we have exponent. So that's 2 asterisks like that. This will raise x to the power y. So we can see what that gives us 729. And then next we have floor division. So what I'm going to do here is actually make this a 10. Have a guess at what you think this is going to give, but this gives us 3. The reason it gives us 3 is because this will give us the integer result of whatever the division is. Imagine this was like 9.333 or whatever it may be. It just simply removes all of the decimal points and just gives, or sorry, it'd be 3.333, removes all the decimal points and just gives us whatever that integer result is. Next is mod. This is the percent sign. This returns to us the remainder after a division. In this case, 10 mod 3 is going to be, well, the answer is 9 and then remainder 1, right? So that is why we get 1 from this here. I think that's it for those operators. Now I will simply show you how we can do, say, order of operations. So if we want to do order of operations, we can use brackets, or if we want to evaluate things in a specific order. This does follow the simple order of operations, which the acronym I know for it is BEDMAS, which is BED. And I hate this autocomplete. It's making it very hard to do this. MAS. Okay, so what this stands for is brackets, exponents, division, multiplication, addition, subtraction. Python does follow those standard order of operations if you just write an expression, but of course it's always easier to use brackets and spread things out. So I can say something like x mod y, and then I can multiply that by 2. Since I didn't say it, the integer division and mod operators are in the lowest order of operations. So if you use mod, that is going to be below addition and subtraction. Pretty sure that's correct, but someone can correct me in the comments if I'm wrong about that. But anyways, you get the point. You can use brackets, and that is how you can perform and do arithmetic in a certain way. All right, next thing I need to cover here is simply just an example using input. So what I'm going to say is num equals input, and we'll just say number colon like that. And what I want to do is simply print the result of num minus 5. So I want to take whatever number they type in, and I want to subtract 5 from it and print that to the screen. So let's try it. Num equals 5. Notice that it says unsupported operand types for minus, string and int. So what that's saying is that num is a string, even though it looks like an int to us. I'll explain why in a second. And we cannot subtract the number 5 from it. That just doesn't make any sense. The program doesn't know what to do with that. So think about this. Why is num a string? We typed in 5. This should be an int value from what we understand about our data types. Well, this input automatically returns to us whatever we type in a string. So just imagine that whatever we do here, it's going to give us a string. And that means that if we want this to actually be a numeric value and be able to perform arithmetic on it, we need to convert it to an int. So there is this fancy function called int in Python. This will take some string, assuming that there is an int inside of that string, and it will convert it into its integer representation. Let's have a look now. When I type a number, let's say 10, of course, we get the value 5. It took num, which was 10. So the string 10, I'll type it out like here. We have the string 10, and it simply converted that to the actual integer value 10. Now you can imagine we have other functions in Python that do this as well. We have, say, float. That's going to take whatever we have here and convert it into a float. Now notice what happens when I do this. If I do float 10, we get 5.0. Whenever you have at least one float in your arithmetic, it's going to automatically return to you a float. It needs to keep the level of precision that was in the original, operation or in the original value. So just that's something to keep in mind whenever you're doing, plus, minus, multiplication. If there is one float as the operand, so on the left or right-hand side of the operator, then you are going to get a float result back. All right, that is all I wanted to show for this. Now let's move on. So the next thing I want to cover is something called string methods. Before I do that though, I need to define what a method is. So let's create a variable. Let's make this equal to hello, and we can just say hello equals the string hello. Now I want to show you this function called type, which will tell us the type of a variable. So if I print the type of hello, well, you can imagine what type this is going to be. It's simply its data type. Let's have a look here. We get class string. You can ignore the angle brackets in the class. If you're more advanced, you probably already know what this means. But essentially what this is saying is that this string or this variable here, hello, is an instance of the class string. Again, big words. You don't have to know what those mean, but for anyone more advanced, hopefully that makes sense to you. All right, so how do we use a method on a string, and what is a method? Well, a method simply is something with a dot operator. So we have dot we have some name, whatever the method name is. In this case, it's going to be upper. And then we have an open and close bracket or parentheses, whatever you want to call them. Now, I just want to show you what these methods do. So if I say hello.upper, this is a method that we can call only on strings. So since this is a string, I can use this .upper method on it. And imagine what this is going to do. What this actually does is it uppercases, or puts the entire string in completely uppercase. So if I have a look now at hello and we print it out, we can see we get hello in all capitals. Now I don't need to call it like this. I also can do hello.upper. Now the reason this is going to give me the same thing is because, well, this is storing the value of the string, which is hello, and then it was just making it uppercase right here. Now what happens is it says, okay, well, what is hello equal to? Oh, well, hello is equal to the string hello. So you can think of it as a substitution. This string just goes where that is, makes it upper, and then prints it out. There we go, upper. Now let's have a look at what .lower does. You can probably imagine already, but it simply makes the entire string lowercase. These are useful when you're getting user input and you want to validate and check if it's equal to something, which we will do later on. So a few other methods. We have .capitalize. You can imagine what this does. It simply capitalizes the first letter in the string and then makes the rest of it so it looks good, right? So if I had a sentence and I said like hello world like that, let's have a look at this. It's going to give me hello world properly. And if I added a capital W like that, it removes that and it just kind of formats it as if a sentence would. Next, we have this method called count. What count does is it will count a specific string within the string. So it looks for a substring in the string and how many times that occurs. Let's see, I wanted to see how many double L's were inside of this string. Well, I can say hello.count double L, and then that will count and tell me how many are in here. Now have a look and guess how many you think are in here. Well, there's actually 0. The reason there's 0 is because these are capital L's and this was looking for lowercase L's. So that's why it's very important to make sure you're differentiating between capitals and lowercases, because 2 lowercase L's are not the same as 2 uppercase L's. But if I wanted to fix this problem, I could make the entire string lowercase. So I could say hello.lower, and then I could count all of the double L's in the lowercase string. So now let's look at this. In this case, we get the value 1. Let's make this a little bit better and let's look for all of the, is there any other ones that we can look for? I guess we can look for how many O's there are. All right, in that case, we get 2 O's. So those are a few basic string methods. There are some more, but I just wanted to show you how you use these and the fact that you can chain them on each other. Because what happens is this will return a string. You can imagine that the substitution of this just looks like, hello world, and then it's going to count all the O's inside of hello world and return to us that value, which in this case was 2. All right, so now we're going to move on to conditions and conditional operators. Now, before I mention that, I just want to go over something that I forgot in one of the previous sections. This is simply string multiplication and string addition. This is important, so I'm just going to cover it quickly. But essentially, let's say I have a variable and that's equal to hello, so x equals to hello. I have another variable and this is equal to, actually we can say 3. Well, there's this cool thing in Python where what I can actually do is multiply a string by an integer, and that will simply repeat the string, the integer numbered times. So if I say x multiplied by y, even though these aren't the same data type, which I said before might cause problems, since it's a string and it's an integer and the string is on the left-hand side, we can do this. So I can say, this gives us hello, 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 because we multiplied the string by the integer. So just something to keep in mind that we also can add 2 strings together because that actually makes sense. So if I say hello and then I say yes, well, I can add these 2 together. This is known as a concatenation. So let's have a look at this. And I get hello and then yes. So you can do that. You can add 2 strings together and you can multiply a string by an integer. Just need to throw that in there because that obviously is something that's important to understand. All right, next we're going to talk about conditions and conditional operators. So a condition is simply something in Python that evaluates or compares 2 variables or data types and returns to us either a true or false value based on the comparison. So to, give you an example of a comparison, is x equal to y? Is x less than y? Those are comparisons, and the answer to that is either yes or no, or in our case, true or false. So we have that true, and we have these false. This is Boolean, so the result of a comparison is simply a Boolean value. All right, so let's look at what these operators are. We have 2 equal signs, which checks for equality. Is the left-hand side equal to the right-hand side? We have not equal to, which checks for inequality. So is the left-hand side not equal to the right-hand side? We have less than or equal to, greater than or equal to, less than, and greater than. Now, there's a few other random ones. We're not going to go through those, but these are the core conditional operators. And let me show you an example of a condition. Let's say I have x equals hello, and y equals hello. I want to check for the comparison, so I might do something like print x equals y. Are these two things the same? Let's see. Yes, they are. We get the value true. Now let's do the not equal to sign. Are these things not the same? No, they're not, so we get false. That is the basics of checking for equality. Now, what if I add a capital L inside of this string? Well, we know that lowercase and capital L's are different, so if I do this, we get true, which means no, these two strings are not the same. They are different. If I do double equal sign, then we get false. Now, interesting thing with strings, we can actually compare them using the greater than sign and the less than sign. Now, it's not super intuitive, so I have to kind of show some more primitive examples here to give you an illustration of how this works. But if I have something like A, and I say, is A greater than, let's actually go with capital Z. What do you think the answer to that is? Well, that's actually true. Now, the reason for that is every single character inside of Python is represented by what's known as an ASCII code. We can actually have a look at what this ASCII code is by looking at what's called the ordinal value of a character. So if I print out the ordinal of Z, we can actually see that that's 90. And if I print out the ordinal of A, we can actually see that that's 97. So what that's telling us essentially is that this uppercase Z is actually represented by the number 90, and the lowercase a is represented by 97. So what we do is we would compare the two ordinal values of these characters and see that, well, actually A is greater than Z. Now, if we do this, so I say A greater than B, then that's going to be false because B is actually represented by 98. There is some logical ordering for these characters, but I just want you to understand that we can compare strings using greater than, less than, equal to, all of those, but just understand that we're comparing the ordinal value of the strings. Now, let's say we have something like AB. What we're going to do is simply just go from left to right and compare all of the characters. So we would say, okay, is A greater than B? Yes, it is. Imagine these two were the same. So we had A and then we had D like that. If these were the same, then we would go on and compare the next character, which would be B. In this case, we get false because obviously the D is greater. All right, so that is how that works. Now let's just show a few examples with numbers. Let's just say 7.5 equals 7. Is that true? Obviously that's false. Let's say 7.5 greater than 7. Obviously that's going to be true. And what about 7.0 equals 7? Have a look at that. We get true. All right, that is the basics on the conditional operators and conditions. Of course, you can store these things in variables. I can say result equals 6 equals 6 and print result like that, and we get the value true. Okay, let's move on now to chained conditionals. So a chained conditional is essentially combining multiple conditions together to create one larger condition. What I have right here is a basic example. I have three conditions, right? I have result 1, result 2, and result 3. Result 1 says is x equal to y. Result 2 says is y greater than x. And this one said is z less than x plus 2. You can imagine that these have brackets around it. It works the same. So all of our conditional operators have a lower precedence than all of the arithmetic operators. So if I do something like z minus 2 less than x plus 2, well, that's not going to say z and then negative 2 less than that. It will evaluate on the left-hand side and it will evaluate on the right-hand side, and then it will combine and use, this conditional operator. So hopefully that makes sense, but just keep that in mind that you can actually write expressions on each side of a conditional operator. Okay, so now that we have that, essentially what I want to do is say, okay, how can I make a condition that uses result 1, result 2, and result 3? So obviously all of these are equal to true, false, they're equal to something like that. So what I can actually do is use three separate keywords, so and, or, and not. So these three words are what I can use to chain conditionals together and create larger conditions from specific conditions themselves. So what I can do is do something like this. I can say result 4 equals result 1 or result 2. Now, what does the or operator do? Well, the left-hand side and the right-hand side of or have to be a true or false value, which they are because these evaluate to true or false. What or will do is it will look at the left-hand side and right-hand side. It will say, okay, if the left-hand side is true, or the right-hand side is true, this whole condition is true. Of course, if they're both false, that's the only situation where this whole condition here is going to be false. So in three scenarios, because there's 4 possible scenarios here, it's going to be true. In the other scenario, it will be false. So if both of these are true, obviously at least one of them was true, so that evaluates to true. So let's actually just print result 4 and have a look at it. Great, we get true. Now what we can do is we can add another or if we want, and we can say result 3. Now what this says is, okay, If result 1 or result 2 or result 3 is true, this whole thing is true, which of course it is. Now let's see how we can combine other stuff into this. We can actually use this not keyword. What this does is it takes whatever is on the right-hand side of it. So in this case, it's going to be a true or false value, and just flips it. So in this case, if result 2 is true, which it is, it's just automatically going to become false. So if I can show you on a more basic level. If I just print, instead of result 4, I print not true like that, this will print the value false, which you can see down there. And if I print not false, then this will print true. Now what I can do is do something like this. I can say not false or true. So let's have a look at that. And there we go, we get false. So it takes whatever this is, which is true, and then it just reverses it and makes it with the not. Now those are two that we've talked about, so or and not. Now what about and? So and essentially says, okay, is what's on the left-hand side and the right-hand side true? If both of it is true, they are true. The whole condition, is true. Otherwise, it is false. So only in one scenario out of the 4 possible scenarios here with 2 variables or 2 values on the left and right-hand side is this going to be true. So let's have a look at this, and we get true because obviously this is false. Then we not it, and that turns to true. Now, of course, we can do a combination of and or. Now, when we use these combination of different things, right, so not and or, we have to know which is going to come before what, so kind of in the order of operations. Now, the way it actually goes is not is first, and is second, and or is last. So just keep that in mind because that will be important based on the way that you write your expression. So essentially, if I say false and true or true, then what we're going to actually do is evaluate the false and true first, and then we will evaluate the or of whatever this is and then that. So in this case, this would be false. So then we would get false or true, and then this would turn into true. Then we would have the not, and that would turn that into the false. So now we're moving on to the fun stuff, which in my opinion is the if, else if, and else statement. Now this essentially allows us to actually check if something occurs or if a condition is true. And if that is true, we can do something specific. Otherwise, we might not do anything, or we might do something differently. So for the example I'm going to do here, I want someone to type in their name, and I want to say if their name is equal to, in this case, Tim, I will tell them they are good at Python. I don't know, something random. So in this case, to do that, what I will start doing is writing an if statement. So the syntax of an if statement is if condition, like that. I know that's spelled wrong, but that's fine. Condition, colon, indented block, whatever I want to happen in the indented block, and then that is the basic syntax of the if statement. So for here, if I want to check if x is equal to Tim, I will say if x equal to, and then the string Tim with a capital T, I will simply print, you are great. So now what will happen is if and only if x is equal to Tim, will I print you are great. Now in any situation, so regardless of if the name is equal to Tim or not, I will always do this. So I will print that statement. Hopefully that's self-explanatory. So let's go ahead and do Tim. We can see you are great, always do this. Now let's do another name. Let's go with Joe, and it says always do this. It did not print this statement. Now the addition to the if statement is, of course, I can add more stuff underneath this indented block. So I could do another print statement, and then that would add a space. So let me actually just show you how this works. If I do Tim, now you see we get that space by just printing an empty print statement essentially. Okay, now what we can do though is we can say, okay, how about I only want to print you are great, or I want to print some other message. I don't want to print 2 things. Well, what I can do is I can add this else. This else must come after an if statement. And essentially what it allows me to do is say, okay, if this isn't true, do this. So it's an if else, right? If true, do this. Otherwise, do this. Never will I do both. So in this case, I'll just print no. You know, not very intuitive, or it doesn't really make much sense, but that's fine. So now I'll go ahead and I'll say name Tim. It says you are great. And let's actually just go with no, and then it prints out no. All right, so that's the basics on the if else. Now, let's say we actually want to check multiple things. So maybe we want to check a bunch of different names. And if the name is Joe, maybe we want to say, you know, thanks, Joe. I don't know, something random, right? Well, what we can do is use this elif statement. The elif statement can be used as many times as we want, but it must come after an if, and it must be before any else's. So I can't just go ahead and start writing these random elifs everywhere. It only is going to come after an if statement. So there's only ever one if, only ever one else, but as many elifs as we want, and you'll see how this works in a second. So the elif syntax is the exact same, except it starts with the el. So I'm going to say elif x equals Joe, and then I'm going to print by Joe. Why not? So now let's run this. And let me just show you what happens when I go with Joe. It says by Joe, and let's just print something random. It gives us no. Now, of course, I don't need this else statement. I can use an elif without the else statement. That's totally valid. In this situation, if I do something random, just nothing will happen. But if I put Tim or Joe, then it will give me the valid response. Now let's add another elif. Let's say elif x equals, I don't know, let's go with Sarah. We can print random, okay? And now let's try this out. And that works. Now, of course, we could add the else at the end, but that is the basics for the if, elif, and else. Now, of course, you can chain and add stuff inside of another if statement. I could put another if statement inside of this, but just make sure you keep the indentation correct, because that is how it determines what we are going to be printing and what we are doing if this statement is true. So in these next few sections, I'm going to be talking about collections, how we deal with collections, looping over collections, and all of that fun stuff. But what is a collection? Well, a collection is simply an unordered or ordered group of elements. Now, the two collections I'm going to discuss here in this section is list and tuples. So if we have a list looks something like this. It is simply square brackets. Now, inside of the square brackets, we can have a series of elements. Elements are simply some data type. So I could have the integer 4, I could have the value true, I could have some string high, and these elements do not need to be the same type like in many other languages. So this is a list, and the way that the list works is that it can store a bunch of different elements, and a list is an ordered collection, which means the order in which we enter things into the collection matters and is maintained. In fact, it's very important in the list. So how do I actually access elements in the list? How do I deal with the list? What are some things we can do with it? Well, of course, I can define a list by simply opening up some square brackets and then defining some elements inside. I also can just leave square brackets like this empty. That would give me an empty list. The first thing to look at on a list is this function called len. Len will tell us the length of the list. This also works on strings and a few other things as well. But if I look at the len of x, that tells me 3. Now, just to kind of show you here, if I say y equals high, and I were to look at the len of y after I look at the len of x, we obviously get 2. So len is a function in Python that we can use to look at the lengths of stuff. All right, so that is one of the things we can do on a list. What we can also do is we can append things to it. What append does is add to the end of the list. So if I want to add, say, the element hello, I can say x.append. Now I can print out x, and if we have a look, we get 4 true, hi, hello. Of course, we added this element to the end of the list. I can also extend the list by another list. So let's say I have a list here, and inside of this list, I have 4, 5, and just a bunch of other stuff. Well, when I extend it, what that will do is take all of the elements from this list and simply append each of them to the end of the list. So you can imagine extend, its internal implementation just loops through all of this and appends all of those elements to this list. Now, what about removing something or popping something off of the list? Well, I kind of already gave away what one of these things is, but what pop does is remove and return the last element in the list. So if I actually go ahead and print x.pop, what this will do is it will print high, and it will remove high from the list, and you can see that when we print x again. So we get high, and now our list has high removed because we popped it off of the end. Now, another argument for pop is actually the index of what we want to remove. When we look at a list, every single element in the list is identified by a number. That number is known as its index, otherwise known as its position in the list. When we start looking at indexes in a list, we start counting at 0. So the first position in the list is 0, the next is 1, and the last is 2. If we want to know the last index in a list, we look at the length of the list and subtract 1. In this case, we have 3 elements. The last index would be 2, the first is 0. So if I go ahead and say x.pop 0, what that's going to do is remove the first element from the list, which is 4. So now we remove that, and all of a sudden, if we look at this new list, the first element at position 0, index 0, is going to be true. Now, if we simply want to access elements of the list, maybe don't want to remove them, we just want to look at them, we can say x, put these square brackets, which means we're going to access something, and we can put the index of the element that we want to access. In this case, we'll access true. There we go, we print true, and that is the basics. Now, what I can also do is do something like x0 equals and change its value to say hello. Now when I print x, we'll get hello, true, hi. Let's have a look, and there we go. The reason I can do this is because lists are what's known as mutable. This means this x right here does not actually store a copy to the list. It stores what's known as a reference to the list, and the actual items itself are stored somewhere else. So for people that are more advanced and understand that, I'm hoping if you guys have come from another programming language, that makes sense. But lists are mutable, which means they can be changed. I can change all of these elements. And if I do something like y equals x, I go ahead and I make that change to x, but I don't make it to y. You're going to notice that x and y will be the exact same. So I have hello, true, hi, making a modification to x, made a modification to y because x and y are storing a reference to this list, not a copy of this list. If I wanted to copy the list, I would have to do this. I would have to do 2 square brackets, a colon inside. We'll talk about how this works later, but now notice if I made this copy, that change does not apply to the other list. There's a lot of other stuff that you can do with lists, but those are the basics, and hopefully that makes sense. Next, I'm going to talk about tuples. So tuples are similar to lists, except they are immutable. So a tuple uses round brackets instead of square brackets, and it works pretty much the exact same, except we cannot append, we cannot remove, and we cannot change elements. So a tuple is really an immutable list. You can think of it like that. It means it cannot be changed once it has been defined. If we want to change it, we actually have to redefine it. So what I can do is I can print out, say, x0, and that's fine. That will give me the correct answer. So that'll give me 0. But if I go ahead and do something like x0 equals 5, and I try to do that, you're going to notice we get an error because the tuple object does not support item assignment. Reason for that is because, again, it is immutable. I also cannot do something like x.append. I can try, but you're going to notice that, again, we'll get another error. Tuple object has no attribute append. So this is a tuple. They're not used a ton, although they are used sometimes. And just to note here, you can have lists inside of lists. So I can say something like, I could have a tuple inside of a list. I could have a list inside of a list inside of a list, and I could have elements inside of this. They don't need to be uniform size. Sometimes in other programming languages, when you're looking at arrays, if you have embedded lists, every element has to be another list, stuff like that. Just wanted to point out that you can do something like that. And I think that's all I'm going to cover right now for list and tuples. All right, the next topic I have for you is for loops. Now, a for loop, if you've learned in other programming languages, allows us to iterate a set number of times. So we will be talking about a while loop. The main difference between a while loop and a for loop is a while loop is running an indefined amount of times. We don't know. We're going based off of a condition, which we'll see shortly. A for loop, we know how many times we're going to loop, at least relatively. So what I'm going to do is I'm actually going to show you how we can just create a basic for loop to print the numbers from 1 to 10. Say for I in range, and then inside of here, we simply put 10. I'll talk about what this range function does in a second, but let me just show you how the for loop actually operates. So now I can show you that this prints 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, does not include 10. So the way we set up a basic for loop, if we're just going to be iterating through a count, is we say for I or for some variable. This is going to be our iterator or our counter variable, whatever you'd like to call it. In, this is a keyword we always have, for I in, and then some word here. In this case, we're going to put range. Range is a function that actually creates a collection of numbers based on the input that we give it. The input to range is the following: start, stop, step. So we're allowed to put up to 3, and we can have less than 3 arguments inside of this range function. Essentially, start, stop, step is saying, okay, what number do we want to start at? What number do we stop at? What number do we step at? Now, if we only have one argument, so we only pass one number, by default, that is the stop argument. We usually start at 0, so by default, our range will start at 0, and we will go to whatever number we put here. Most of the times, you're just going to put one number, and this defines the ending range. So in this case, it says, okay, we're going to start at 0, and we're going to go up to 10, but not include 10. Notice we didn't print 10. Now, if we had 2 arguments, that's going to be default start, stop. So I will say, okay, we will start here at 1, and we will stop at 10, but not include 10. If we add 3, we'll include a step, and that tells us how much we should increment every single time. By default, we increment by 1, but we can increment by 2, and we can increment by a negative number as well. Let's actually say that we wanted to start at 10, and we wanted to go to -1, and we wanted to step by -1. Well, let's have a look at what this looks like, and just test it out. Okay, so running, you can see we started at 10 right there, and then we went all the way down to 0. Now, of course, we can start at -10, and watch what will happen here. We do nothing. The reason for that is we started at -10, we were going to -1, and we were stepping by -1. But since we were already past -1, we aren't going to go there, obviously, and we just immediately stop. So that is kind of how the range function works. So for I in range, again, start, stop, step. By default, if you just put one argument, that's going to be the stop. If you put two, that's start, stop. You can mess around with that and see how it works, but I think that's enough of an explanation. The next thing we can do is actually loop through a list. So let's say we have for I in, and now instead of range, we'll simply just put a list. We'll say for I in range, and we can do 3, 4, and just a bunch of numbers here. Now, if we print I, it will simply print all of the numbers in that collection or in that list. It will step through one at a time and print all of them. Now, let's say that maybe we didn't want to do that. Maybe we actually wanted to keep track of what index we were at. We could say x equals the list. We could say for I in x, and then, well, sorry, that actually would not be the right way to do it. We could say for I in range the len of x, and then instead of just printing I, we could print x square brackets I. Let's have a look at this here. You see how that works. So the way this works is we're going to go up to, but not including the last index of x, or the length of x, sorry. So in this case, 1, 2, 3, 4, 5, 6. So this right here will say 6. So for I in range 6, that means the maximum value of I is going to be 5. So we say x0, x1, x2, 3, 4, 5, and print all of the values out. Now, there is another fancy thing that we can do if we want to avoid using that. It's called enumerate. What enumerate will do is create indexes and values for all of the elements in our list. So we can say for I, comma, element in enumerate x, and then what I can do is I, comma, element, and you'll see how this works. What we do is we get 0, 1, 2, 3, 4, 5, and then all of the elements. So this works kind of like a combination of the two for loop styles I just showed you, where we actually have a range. So we go from 0 up to 5. Those are all the indexes in the list. And then we print all of the elements for each of those indexes in the list. And we just have two variables here that denote that. So the next topic to discuss is while loops. Now, while loops are pretty straightforward. Essentially what they are is while condition equals true, go ahead and do something. So we're going to have some condition here before this colon, and then after the colon, there's going to be an indented block, and whatever's in that indented block will run inside of the loop while that condition is true. To illustrate this, I will say I equals 0, say while I is less than 10, we'll say print run, and then we will say I plus equals 1. This is another way that you can add 1 to a variable. So you could say I equals I plus 1, or you can do I plus equals 1. You can also do something like I multiplied equal by 1 or divided equal by 1. So multiplied by equal 2, what that's going to do is say, okay, multiply I by 2. We could do something like that if we wanted as well. Just showing you some more syntax for some interesting things that we can do in Python. But that's the basics of a while loop. If I go ahead and run this, we can see that this is going to run 10 times. And there isn't really much more to talk about for the while loop other than the fact that we can implement a break statement. So we could also write the same code like this. While true, I plus equals 1, and then if I equals 10, break. And that will simply break out of whatever the closest loop is to us. Imagine we had another while loop like this and we said while true inside of here. Then this would break this while loop, not the other while loop. Hopefully that's making sense. Anyways, let's move on to the slice operator. So the slice operator is personally my favorite part of Python. There is implementations in other languages, but none of them are as nice as Python in my opinion. And what this allows us to do essentially is to take a slice of a collection like a string or a list or a tuple and do something with it. So let me just show you what I mean. The slice operator is simply the square brackets like this with a sequence of colons and numbers within it. The way that it works is we have a start, a stop, and a step, just like the range function that we looked at before. So if I put something like x here, and then I go start, stop, step, what I can do is say, okay, I want to start at 0, I want to stop at index. These are all indexes that we're putting in here, 3, and I want to step by 2. Now, actually, let me just stop at index 4 just so we get some more values in here, but let me show you what this looks like. We get the value 0, 2 when I have 0, 4, 2 in my slice. What this is saying, again, is start at the first index, which is 0, go to the fourth index, but do not include it, which means stop as soon as we hit this and step by 2. So we're going to start at 0, then we're going to go to 2, and then we're going to go to 4, but since 4 is the stop here, we are not going to include that in our slice. Now, when we do the slice operator, we don't have to include all of these different things as arguments. In fact, what we can do is just include a stop, just include a start, and all of that. So just like the range function, if we don't include anything, so we just include a colon like that, and then we put something on the right-hand side, that is saying stop at whatever index we put here. So if we do this, it says start at the beginning and stop at the end. Now, if we do something like 2 colon, that says start at 2 and stop at the end. So whenever we leave a blank, we're assuming it's either the end or the beginning, or 1 in the case of a step. So if I did 2 colon colon, maybe I did 2 colon 4 colon, this is saying, okay, start at 2, stop at 4, and then step by 1. But I don't even need to include that. I could just do 2 colon 4. But now let's say I wanted to go 4 and then colon 2 colon -1. What this is saying is, okay, start at 4, go to 2, and step by -1. So now what this is going to do is start at 4, which is actually this, and it's going to give us 4, and then 3, and then it's not going to include 2 or any of the other ones, so that's what we'll get. In fact, let's look at this. We see we get 4, 3. Now, one of my favorite things with the slice operator is to reverse a list. All we have to do is colon colon -1. This means start at the beginning, stop at the end, and then step by -1. So this will actually start stepping backwards, which is kind of interesting. So when we look at that, we get 8, 7, 6, 5, 4, 3, 2, 1, 0. That is an easy way to reverse a list in Python. Now, of course, all of this works on a string as well. Let me show you that with S. You see we can reverse the string like that. And we can also just do the standard arguments that we would typically do. Maybe we'll just step by 2. So start at the beginning, stop at the end, and step by 2. We get HLO. So that's the basics of the slice operator. There's a bit more stuff that we can do with this, but that is kind of how it works. And I believe this works on tuples as well. We can just try it out to make sure that I'm not lying to you guys. But if I do that, you can see that that does indeed work, and we can use the slice on kind of any collection of elements. All right, so now we are moving on to sets, which are an underrated but extremely useful data type in Python. Now, a set is simply an unordered, unique collection of elements. What that means is there is no duplicate elements. We do not keep track of order or frequency of elements. All we care about is if something is there or if something is not there. The reason we do this is because a set is extremely fast to do what's called lookups, removals, or additions. When we're talking about a list, let's say we have something that's, has a bunch of elements in it. If we want to say remove the first element from the list, that actually involves shifting the position of all of the other elements because we're keeping track of the positions of these elements. With a set, since there is no notion of position, adding and removing something is as simple as just adding or removing that element. There's no other operations that need to be done, which mean it's very fast to use. So think about a set to be used only in a situation where you care if something exists or doesn't exist, not about the frequency or order in which that item exists. So to create a set is pretty straightforward. We can say x equals set, and we use the open bracket and close bracket. Now, the reason we don't actually write something like, say, s equals and then this, which is really the representation for a set, is because what this will do is create a dictionary. Now, technically, if we want to create a set, we can do something like this, and this will create a set for us that initially has the elements 4, 32, and 2 inside of it. This is what's known as a set literal. If you're not going to be creating an empty set, it's totally fine to do it like this, so long as you add an element inside. But if you are creating an empty set, then you need to use this constructor. Otherwise, you're going to end up creating a dictionary, which is not what you want. To prove this simple point to you, I will print out the type of just an empty set representation, and you'll see that it gives me dict like that. Of course, that's not what we want. Anyways, let's have a look at this set, and I'll just show you what I mean by unique unordered collection of elements. So 4, 32, 2, 2. If we print that out, we get 32, 2, 4. So obviously a different order than how we added it in there. And notice that the duplicate 2s were removed. Now, the set operations are pretty straightforward. We can add something to a set with s.add or set.add. I'll put 5 inside of here, and let's just keep printing out s. There we go. We can see we added in there. We can also do s.remove 5, and that will, well, since there's nothing in there, give us a key error. Now, if there is the element in there, so we can do it like this, it will remove that element for us. And then there's a few other things that we can do as well for a set. One of the good ones is actually checking if something is in a set. What I can do is say 4 in S. What this will do is simply check if the element 4 is in the set and give me a true or false. In this case, it is true. And remember, this happens in what's known as constant time, which means it's just extremely fast to do this as opposed to a list. So we can say 33 in S. That's going to give me false. Now, the parallel I want to make here is if I had S equals to 4, 32, 2, 2, like that. So actually, let's go S2. And then I said print. And let's just go 2 in S2. This operation, the one that's actually in the set, is going to happen much faster than this one. Of course, this isn't a big deal right now because these collections are quite small, but as these get extremely large, just understand that using a set is very beneficial when it comes to looking things up, checking if something's in there, removing and deleting. There's a few other operations we can do on sets. Let me just define S2 and I'll just quickly show you a few of them. We can do, for example, the intersection or the union of these sets. So I can say S.union S2, and we'll go ahead and have a look here and we can see we get the union of these two sets, essentially adding them together. We can do the difference of the two sets if we want. We can do the intersection, and we can do the symmetric difference and all that other fun stuff that you can do with sets. Now, I'm not going to get into all that stuff. Just know that these are sets, and that's some of the stuff that you can do with them. So now I'm going to talk about dictionaries. Now, if you're from another language, what may be familiar to you here is a hash table or a map, something like that. They're very similar to dictionaries, but a dictionary is essentially a key value pair. You have some key, you have a colon, and then you have some value that it corresponds to. Now, of course, that value has to actually be a valid data type, but it could be something like a list. It could be a single value like that. And the way that you access and create new key value pairs is something like this. I can print out, say, X, and then the key inside of here. In this case, it's actually called key. And what that will give me, if you look down here, is simply the value 4, because, well, that's what corresponds to this key. So you have keys and you have values. Now, to add a new key is pretty straightforward. What you can do is you can say X. Inside of square brackets, you can define whatever key you like. It can already exist if you want. We can say something like key 2, and we can make that equal to 5. Now note that these keys do not need to be the same, same data type. So I don't have to have 2 string keys. I can have integer keys. I can have whatever keys I want. I can do something like x2 equals 8. And there we go. You see that works perfectly fine. In fact, I can make this a list just to prove to you that the values don't have to be the same either. And there you go. Now, just like a set, this actually works using a hash, which means this is very fast to retrieve, add, and modify values within the dictionary. In fact, it's so fast you can kind of assume that it's in constant time, although there is a chance that there will be something known as hash collisions, although I'm not going to talk about that because that's probably a little bit more advanced than what most of you know. Anyways, what we can do here in terms of operations on the dictionaries, we can check if something is in the dictionary. So I can say, okay, is some key in the dictionary? Key in X. There we go. Print that out, and that says true. A few other useful things that we can do is we can get all of the values from the dictionary. So we can say x.values, print that out, and it says dict values, and it gives us a list of 4. Usually when you do this, you're going to want to actually create a list out of this because that is a different data type that's returning to us. And there you go, we get the value 4. Now, similarly, we can do dict.keys, so x.keys, and there we go, we get a list that has all of the keys. In terms of iterating over or deleting values, I'll first show you how you delete something. To delete something, we can say x and then the key that we want to remove. In this case, it will remove this key. So let's go ahead and do that. And well, I guess it didn't really show you that it was deleted. Let's just print it out to prove that. There you go. And we get an empty dictionary. Of course, like I showed you before, we can use that in operator. And to loop over it, there's actually a few interesting ways that we can do this. So I can say for key value in x.items, and then what this will do is simply return to me all the keys and values. So I can print key value, and you'll see we'll get key 4. So if I want to loop through all of the keys and all of the values, I can use .items. If I don't want to do that, I can just say for key, and then I can say in x. What this will do is simply just give me all of the keys in x, and then if I want to access the value, of course, I can say x key like that, and that will give me the value, and we get the same thing popping up there. That is kind of the basics for the dictionaries. There's a few other methods as well, but I'm not going to talk about those. That is a dictionary. And this next one is a fun one. This is comprehensions. Now, as far as I know, Python is one of the only programming languages that actually has this. A lot of people absolutely hate it, but I personally love it. And if you learn to love it, you can use it quite well. Now, to do a comprehension, essentially what that is a one-line initialization of a list, of a tuple, of a dictionary, of many other things. So let me just show you what I mean. I can do something like x equals a list, and then I can say x for x in range 5. Now, if I go ahead and I print the value of x, you're going to see what we get here. Let's run it like that. We get 0, 1, 2, 3, 4. The way this works is essentially we can actually define a for loop inside of this list. And what it will do is say, okay, we're going to loop through as if we normally would. And whatever we have on the left-hand side here is actually the element that we're going to add into the list. So I could do something like x plus 5 for x in range 5. And there we go. We get 5, 6, 7, 8, 9, 10. I can also do something like, x mod 2 or x mod 5. There we go. I could also, grab something else. I could say 0 for x in range 5. That would give me a list of all zeros. So you can see how this might actually be useful. Now, if we want to go into a more complex example, I could do a list, and then inside this list, I could say 0 for x in range 100 for x in range 5. Now what that's going to give us is 5 of these lists that each have 100 zeros inside of them. You can see that's quite large. But that is kind of how that works. Now we can also go ahead and add some more complex stuff to this too. We can say 0 for, or I can say I for I in range 100 if I mod 5 equals 0. So essentially if I is divisible by 5, then what we can do is actually add it into the list. Let's have a look at that. And there we go. We get all the increments of 5. So you can play around with that and see how that works. But this also works for dictionaries. In fact, let's just do the same thing here. Let's make it a dictionary. And now we'll just go I:0. So we have all these keys that are initialized at 0. When we go there and have a look, we can see that dictionary works. And of course, we could do the same thing for a set. We can just say I for I in range, blah, blah, blah. And there we go. Now we get a set. So we can actually do this for tuples as well, except we're not going to do it in the way that you might assume. If you just go ahead and do this, this actually returns to us what's known as a generator object. It's a bit more advanced for this kind of video, so I'm not going to talk about that. But what we can do if we want to make this work for tuple is we can actually type tuple. We can use the tuple constructor, which is simply this, and then do the comprehension inside of there. Now that will return to us the tuple. You can see I tried to do it the other way before, and that returned to me the generator object. Anyways, that is comprehension. These can be used in a whack of different things. They're definitely interesting and good to know, and one of the best features of Python that is not in many other languages. So now I'm going to start talking about functions. So to define a function in Python, you simply use the def keyword. This means define. Then you pick your function name. In this case, I'm going to pick func. The function names are the same as variable names in terms of how you name them. You can put some positional parameters inside of here if you want, or you can leave it empty. You add a colon, indented block, then anything inside of the indent will run when you run the function. So let's go ahead and actually just run this and show you the basics of this. So that is pretty much how you run and define a function. Of course, you can define multiple functions. You can actually define functions inside of functions if you wanted to. This is totally valid if I wanted to do something like this. And then I could call func like that. Now, of course, this is a more advanced use case, but just showing that you can do that because of the way that Python works. In fact, functions are actually objects, which means you can technically return them. I'll show that in a second, but let me talk about arguments first. So let's say I want to add the argument x, y inside of here. Of course, that means now when I call the function, I need to add some value for x and for y. So let's go 5, 6. And now if I after run want to print those, I can print x and I can print y. Let's have a quick look. We get run 5, 6. Of course, we can return something from a function as well. Maybe I'll return x multiplied by y. Now, if we actually go ahead and print the value of this function, what will happen is it will evaluate what is here, return that to us, and print that out. We get the value 30. Now, note that when you return multiple things from a function, which you can do, I can return x multiplied by y and maybe x divided by y as well. This will return the value to us in a tuple. So if you look here, we get actually two values. We have, I guess, the x, y value here, and that's inside of a tuple. Now, if we want to unpack this tuple and say separate this out into different variables, we could, of course, index at 0 and index at 1, but a much cleaner and faster way to do this is to do something like r1, r2 equals func 5, 6. What this is going to do is take these two values here and simply separate them into the r1 and r2 variable. Now, if I go ahead and I print r1, r2, and I have a look here, you can see that we get 30 and then 0.83334. That is the basics for a function. If you want to do a optional parameter, you can do something like z equals. You can set a default value. I usually set it as none. And what this means is that you do not have to pass z in, but if you want to, you may, and it will override the optional value that you have here. So let's just start by actually printing out z. I'm not going to call it with z to start. You can see that let's run that for a second. We get run 5, 6, none. And now if I add a z, so let's just add 7 there, we see then 7, none, we are going to get 7 printing out right there. That is the basics of a function. And now we're going to move on to some other more advanced aspects of it. All right, so I'm going to talk about something that's really cool called the unpack operator, and then I'm going to talk about star args and star kwargs. But I first want to show you an advanced example of a function. So if I say define func like this, and then maybe I'll say take x, and I define func2 inside of here. This is totally valid, by the way. You can put a function inside of another function. And then inside of here, what I'm actually going to do is say this function is going to print x, and I'm going to return func2, but notice I don't call it. Now, this is just to prove to you that functions are objects, hence they can be passed around just like variables. So what I can actually do here is I can go ahead and I can say print, or sorry, not print, but I can call func4 or func3, and then I can actually call it like this. What this is doing essentially is saying, okay, I'm going to call this function here with the value 3. What this function does is it returns to me another function. So it gives me func2. Notice it's not calling the function, it's simply returning it. Now, I'll actually just show you what I mean first before confusing anyone. Let's print this out before I do the call statement on it. But you can see that this actually tells me this is a function object. It's a func.locals func2. So it's pretty much saying that func2 is defined within func. Now, if I actually call this, because that's just the function reference or object, it's not actually, being evaluated. If I call it like that, we can go ahead and we get 3, and then we get none. Of course, the print statement is going to print none because there's nothing to print from the return of func2. But just have a look here, we get 3. Now, this is equivalent to if I did something like this. I said, x equals func. And then on the next line, I just called x. Since x is equal to a function, func2, I can call it just like I showed you before, and there we go, we get 3. Anyways, that's the advanced aspect I wanted to show. Now what I want to do is show you about star args and star kwargs. So I'm going to put in like this. All right, so before I define what this does, what I'm going to do is just show you what the unpack operator is in Python. So let's say I have a list, maybe we'll call it x, and we just have a bunch, of random numbers in this list. So what the unpack operator does is actually separate all of the elements from a list or from a collection into individual elements. The best example of this is the print statement. If I print asterisk x, which means unpack x, what this is going to do is take all of these elements out, so separate them by individual elements and pass them into the print statement as arguments. So instead of just printing, say the entire list, what it's actually going to look like is print 1, 23, 236, blah, 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 you get the point. That is what this is going to do. So just have a look at what happens when I print that. I get all of these things separated by spaces, like would happen if I just pass them in individually, not being in the list. Now look what happens when I just print x. Let's have a look. See, it actually prints the list out. So what this does is unpack whatever we have in a tuple or a list or some kind of collection and sends it through as arguments to a function. So that's where star args and star kwargs come in, although you'll see that in 1 second. So let's say I have, x, y that we need inside of a function. We got to pass x, y. What this will do is simply print x and then print y. Now, let's say I actually have maybe a bunch of pairs that I want to pass to this function. So maybe I say pairs equals, and then I have like 1, 2, 3, 4. Well, what I'm going to do is do a for loop. I'm going to say for pair in pairs. And what I want to do is call this function with those pairs. Now, the naive way to do this would be to go func, okay, pair 0 and then pair 1. Great, that would work, but that is not the Pythonic way to do this. What we can actually do is do asterisk pair, and what this will do is take 1, 2 and take 3, 4, unpack them, separate them, and pass them as arguments to func. So if you have a look at that, that actually works, and that is why the unpack operator is really useful. You can also use this actually on dictionaries as well. Now I'll show you how it works with dictionaries. It's a little bit more complicated. It involves 2 asterisks. What this does is if I have keys, I can say x, representing obviously the argument x, and then make that equal to 2, and then I can say y, and this could represent the argument y, and I'll make that equal to 5. Now, if I run this, this works fine. I needed 2 asterisks because this was a dictionary, and that is kind of how this works. I guess really need the for loop anymore to illustrate this, but the double asterisk is used for dictionaries. The single asterisk is used for a tuple or for a list. Now, I just want to make the point here that let's say these are not in the correct order, so it's y and then x. This will still work, and that's actually why this is really useful, because you don't have to have it in the correct order, so long as you name the arguments as the keys. So now, hopefully that will explain to us how star args and star kwargs work. So star args and star kwargs. Essentially, imagine you have a function and you don't know how many arguments, positional or keyword arguments you want to accept. This is what kwarg stands for, keyword arguments. Well, what you can do is you can use star args and star kwargs, and what that will do is allow you to pass in an unlimited amount of regular arguments and keyword arguments. So if I actually go ahead and go func, and then I pass like 1, 2, 3, 4, 5, and maybe I'll pass some keyword arguments like, 1 equals 0, 2 equals 1. I know this doesn't really make any sense, but you get the idea. Now, if I actually run this and print it out, you can see that when I print args and print kwargs, we're getting a tuple that has all of the positional arguments, which are these, and all of the keyword arguments, which are 1 and 2. Now, if I wanted to actually use any of these, what I can do is I can unpack them. So first of all, I can unpack args, and what this does, if we have a look here, is it will print out 1, 2, 3, 4, 5. I could try to unpack kwargs, but you're going to see what happens when I do this, and hopefully if you remember the last example, you'll realize why this is not going to work. It says 1 is an invalid keyword argument for print. So what this is going to do when I unpack kwargs is it's going to take all of my keyword arguments, and it's going to say 1 equals 0, and it's going to say 2 equals 1 and pass that to the print statement. Now, obviously 1 and 2, well, those are not valid arguments for the print statement, so we're going to get an error. Anyways, that is args and that is kwargs. You're going to have to look into this on your own and kind of learn about how it works, but that is the basics, and I just wanted to show that to you so that you're aware that you can do these cool fancy things in Python. This next one is going to be very fast, but this is just defining scope and globals. So when we look at a function like this, there's a notion of a scope. So we have x equals Tim, we have defined func, and then we have name as a parameter, and what we're doing is we're saying, okay, we're going to change x to be equal to name. So essentially, if I was naive and I didn't know any better, I would assume that what's going to happen is, well, this variable up here would change when I pass this name to this function. Any of you that programmed before probably know that's not going to work, but if you have a look here, you can see that x does not change before or after when I call func with the string changed. The reason for that is that this x variable is local. It is within the scope of this function, which means it cannot be used access change from outside. The same thing here with this x. This one is actually global. This is on, not defined within any scope other than this file, which means, well, I can't just directly change it from this function. I could, however, access it from this function. I could print it here, but I can't actually change its value, because if I do that, what's going to happen is I'm going to create a new x inside of here, which is equal to name, and it will be local to this function. It will not modify this. However, there is one interesting thing we can do in Python, which is the global keyword. If I global x, now you're going to notice that the expected behavior will occur. Now we get Tim and we get change. What that is saying is, okay, I want to use x as a global variable. So I want to reference x in the global scope. Never use this. This is never good to use, and if I ever see a Python program that has it, I always get upset. But this is something that you can use, and I feel obligated to show you because there is some very, very rare situations where you may need to use that. All right, so now I'm going to spend about 10 seconds showing you how to actually raise an exception in Python. There's a keyword called raise. Maybe in Java you've seen something like throw, and raise can raise an exception if you wanted to do that. So I could raise exception, and then inside of here I could just say bad, whatever I want. Now if I run the program, as soon as we hit that line, immediately I'm going to get an exception, and it says raised exception bad, exception bad. Of course, that is the basics. There is more arguments and things you can do with this. This is a base class, which means you can extend it when you get to object-oriented programming, make your own exceptions, and make all that fancy stuff. For our cases, that's all we really need to know. I could raise, say, like a file exists error, any other kind of error that I want, and then again, add some description for it by just putting a string inside of the brackets. But that's enough for that. Now let's show how we can actually handle exceptions. All right, so now that we know how to raise exceptions, it makes sense to learn how to handle them. So in Python, rather than having like a try catch, we actually have a try except finally block. So what I can do is do something like try. That means I'm going to try to perform whatever code is inside of here. Maybe I'm going to get an integer division by 0 error. So I can do, 7 over 0. That's going to raise an error. Then I can create an except block. I can accept an exception as E. What this is going to do is mean whatever the exception is will be stored in the variable E, and then so I could print out that exception and we can continue running the program. This is the basic try except block. You don't actually need to define something here. I can just say try except like that if I want. I can also accept a specific exception, so I don't have to just put exception. This is general. This means any exception that occurs, I will actually catch. You can only catch specific exceptions if you want, but again, that's up to you. So in this case, you see we get division by 0. It's just printing out, but it didn't actually raise or show us that error. So it did raise it, but we didn't actually see it. Now, if I go ahead and just do this, what we can do is we can say, oh, well, that is the actual problem, and now our program is going to crash and not work. But if we have this except block like this, of course, we're good to go. Now, there also is a notion of a finally block. The finally block will run no matter what. Usually you put cleanup type operations inside of here. Maybe you're trying to write to a file, some exception occurs, and then no matter if this was successful or not, you want to close the file after, you would put that inside of finally. So I could say print finally like that. Have a look here and you can see we get finally. I'm not going to go through this too much. I assume if you're going to be using this, you understand how try, except, and finally work. But that is the implementation in Python, and that is the basics for raising and catching an error. And now we're going to discuss the lambdas. So lambdas are actually a really cool aspect of Python. I'm pretty sure they have them in many other programming languages as well, but it looks something like this. Essentially, a lambda is a one-line anonymous function. What that means is it's not really a named function. you don't define a lambda using the def keyword. What you can do is something like x equals lambda x and then x plus 5. What this means is this lambda is going to take one argument, which is x, and then it's going to return x plus 5, not multiplied by x. Didn't mean to do that. That means if I call x like this, and I go, I don't know, x2, and we print this, let's just go ahead and have a look at this here. Oops, again, did not mean to do that. We see that we get the value 7. Now, I will note that this is not the advised way to use a lambda. We're going to see how to use it in just a second in the next section. But this is the basics of how it works. It's just a one-line anonymous function. So I can do something like xy as well, and then I can do something like x plus y, not capital Y. And if I go ahead and call x with, I don't know, 2.3 or 2.32, sure, that's fine. Let's have a look here. We get the value 34. So hopefully that makes sense on how the lambda works. It looks intimidating, but it's really not that complicated. And in the next one, you'll see why these are useful. And now I'm going to talk to you about map and filter, which are two useful functions in Python, which make use of the lambda function. Now, you don't necessarily need to use the lambda function, but a lot of times it comes in handy. So let me show you what I mean. Let's make a list. Let's add, oops, I wanted to do a few more commas than that. Let's add a bunch of elements inside of here, just make it kind of nice and long so we get some interesting output. And now what I'm going to do is I'm simply going to show you how we use map. So what map will do is we'll take all of the elements of a list and use a function to map them into a new list. So if I say something like MP standing for, map, I can say map, which is the actual function. Now what I do is I put a function inside of here that I want to use for the map. So this will make sense in a second, but I'm going to say lambda x plus 2. So this is essentially saying add 2 to every single one of these elements, or add 2 to x in this case. And then what I do is simply pass x. Now I know x is kind of confusing, so maybe we'll just change this to I so that it's easier to differentiate. But what this is going to do is say, okay, we're going to map all of the elements inside of x, so in this list x, to this lambda function, which means take this lambda function and apply it on every single element of x and then put that into a new list. Now, what I'm going to do is I'm going to print the list representation of MP. Map actually returns to us a map object. We can use that if we're going to iterate over it, but it's usually more useful just to convert it right into a list. So let's have a look at what this does. And there we go. Now we get 3, 4, 6, and you can see all these elements have been added by 2. Now we can do a more complicated one. Maybe we can multiply by 2. You'll see more of a difference, and there we go. Now, the next function I want to show you is filter. So hopefully you get the idea of how map works, but filter, I don't want to say the opposite, but it does something a little bit different. So this function here, which is the lambda, what it's going to do is instead of actually returning some value, it's going to return true or false. And it's going to tell us whether or not we should include the item in our final filtered list or filtered object. So essentially this lambda function, or whatever function we put inside of here, has to return true or false based on the value of an item. So what I could do is say something like I mod 2 equals 0. So this means, only return it if it's even. So this is the function, takes some value I, tells us if it's equal to, or sorry, divisible by 0. And if it is, we'll include it. So let's have a look now. And you can see that we only get all of the even elements in our list. Now, of course, what we can do is also define a more complicated function. So we could say define func, take some value, let's go with I. And we can do the same thing here. We could say return I mod 2 equals 0, but we could also say, I equals I multiplied by 3. So we can do that. And then we can say I mod 2 equals 0. Then instead of using a lambda here, we could simply just write func. That's totally fine. So we just put the name of the function that we want to use, and then we run this and it works fine. But this is why lambda is useful, because a lot of the times you don't want to define your own function up here. You just want to define it right inside of the map statement or the filter statement. So that's kind of where you would use this. There's another few use cases for it, but this is kind of the most common and where you'll often see it. So anyways, that is map and filter. And for our last and final topic, I'm going to be covering something called f-strings. Now, f-strings are new in Python 3.6. If you have any version lower than that, you are not going to be able to use f-strings, but they're a really cool way to actually just manipulate and create strings. So what I can do is do something like x equals, I can do a lowercase f or a capital F, it doesn't matter, and then a string. Notice that this will highlight, or maybe it'll be italicized depending on what editor you're using. And well, what you can do is type a string as you normally would, except now if you want to embed an expression, what you can do is do that inside of curly brackets. So I can do hello, and then I could say like, 6 plus 8, and this will actually be evaluated, and now when I print this out, it will give me the answer 14. So this is great because if you have some variables, say like I have, I don't know, Tim equals 89 or something, and I want to embed that in the string without having to concatenate it and convert it into a string with str, I can simply just use the f string and just embed it with all the formatting by putting it inside of these curly braces. So that is kind of how that works. You can go ahead and mess around with this if you want to really see how it works, but essentially you just put an expression inside of these curly braces, it will be evaluated, and then it will turn into a string. Really great, easy way to work with strings. Of course, you can print an f string as well. I could print hello, and then we can do that. And in fact, let's run this and just see what we get. And there we go. We see we get hello 89. So that is f strings. So with that being said, I'm going to conclude the video here. I am officially out of breath. I went very fast through this tutorial with the purpose of making it as quick as possible and not wasting any of your time. If you guys appreciate this effort, please do leave a like, subscribe to the channel, and of course, let me know what you want to see next. I will quickly mention that I did miss a few things in this video, specifically object-oriented programming and advanced language features. If you would like to know about those two things, I have a ton of resources related to them. I will leave them in the description. The first is about an hour-long video on object-oriented programming in Python that covers kind of all the fundamentals and everything you need to know. Then the next one is a whole series on expert level features in Python. I believe that's about 6 videos and covers things like meta classes, context managers, generators, all of that. Anyways, as I said, I hope you enjoy. Leave a like, subscribe. I will see you in the next one.